Good morning, Rachel.
Well, hi, everybody. Hi, Chris. It's so good to see you. Hi, everybody watching. My name is Rachel Peterson. I am with the Cosmic Leap Foundation, and we are here for yet another amazing Cosmic Career Chat. Today, I have Chris Bigler here, one of my good buddies, great friend from undergrad, Chris Bigler, who works at Sierra Space. So, thanks for coming on with us today, Chris.
Yeah, thank you so much for having me. I'm so glad to get to share this with all of you.
Oh my gosh. Okay, Chris, we have to just start with like, where the heck are you? Just tell us where you're at and what we're looking at.
Okay, so here at Sierra Space in Taylor Building in Colorado. It's Louisville. I am currently on our production floor with the Reverence Dream Chaser behind us. Our first vehicle is actually in Ohio being tested right now. We have our Shooting Star number 2 cargo module over there. We'll get to that later. So I'm just here on our production floor hanging out with y'all.
Love it. I love it. I'm so excited. Well, Chris, let's go ahead and I have some slides and stuff that we want to show. And I want to make sure that we get a little bit of a story. For those of you that are watching, we're going to hear Chris's full story into STEM and what he does, but also we'll get some behind the scenes footage. So thanks so much for having us on the floor. All right, Chris, can you go ahead and tell us a little bit about yourself?
So here at Sierra Space, I am a structural engineer. So I've gotten the privilege to design primary and secondary structures for these vehicles behind me, the ones that are at ATF right now being tested. I've kind of become a collector of hats. So from structural engineering, I went and joined the liaison engineering team, which helps the production floor keep moving. So when something goes wrong, liaison steps in to kind of help make sure that the problem gets adjudicated correctly and works with the quality engineering team and the manufacturing engineering team to make sure that any problem, a misdrilled hole, a dropped part, that we correctly fix the problem or just replace the part. From that, I kind of got into the hardware stuff. So I'm our hardware lead for the Mission 1. So all of our tools that go up with the vehicle to make sure that ISS crew members can successfully operate our vehicle, I make sure that we're sending up all the right stuff and that the crew members are adequately accounted for of what they can physically do while floating in space. And then I've recently gotten to be our spacecraft representative to the Operations and Maintenance Database Board. So having designed a lot of the vehicles, being around here a long time, they let me help them make sure that when we add operations or maintenance needs for the vehicles before flight, after flight, and between flights, that the spacecraft itself has someone to defend it from someone else, maybe wanted to do something and, needing some assistance on what that actually means at the global spacecraft level.
Wow. That's really cool. That's awesome. Yeah, that's definitely something we want to hear more about here soon. Can you tell us a little bit about, we're going to hear in this next thing here all you're from, but I just want to point out that you have a bachelor's degree in engineering from Colorado State. What kind of engineering did you study?
I studied mechanical engineering. That's where I met you.
Yeah.
It's CSU.
Took some classes together. RAs together. You're right. And what kind of things do you like to do when you're not doing engineering and working at Sierra Space?
So obviously rock climbing, hiking, being in Colorado, we have lots of outdoor sports. So I love getting out in nature. I love tree climbing. That picture kind of center left is the Via Ferrata in Telluride, Colorado. It's a, 300 or 400 meter long cliff that you just climb across for kicks and giggles.
What?
Yeah. My wife and I are currently doing a lot of renovations on our house, so that takes up a lot of time, but we're not doing that. We love hanging out with friends, playing board games, going hiking, getting outside.
And I will say that Chris is a phenomenal swing dancer, so that's something we'll ask you about too.
Yes.
Right on. All right, Chris. So we got a little snapshot. So can you tell us a little bit about what your journey has looked like? Where did you start? How did you get interested in engineering? And ultimately, how has that led you to where you're at right now?
So I had the good fortune of growing up in a household that had an engineer that worked at Lockheed Martin. So he worked the Pathfinder rover and the camera system for that. So if you've seen the movie The Martian, that camera system, my dad worked a lot on that system, worked a lot of satellite programs, and then ended his career on Orion, the spacecraft that wants to take us into further space with NASA. So growing up in that environment, when something broke or I felt like something needed to break, I would just take it apart and had lots of support from my dad just to be able to see how things worked and play with things, help him build on cars and doing maintenance around the vehicles at our house. Went to CSU up before college with you. Studied mechanical engineering. Loved it. I particularly loved CSU because it had a much more open environment. So it had kind of the Colorado vibe of like being able to like hang out in the huge IM fields, and had a really great program that was very holistic. What is kind of like mechanical engineering is. You can kind of do about everything. So, master of maybe none, but jack of all the trades, and can, give input to a lot of different places. That left picture is our senior design project that me and a bunch of buddies did. That was with the Air Force Research Design Lab, AFRL. It was to bridge the gap. Was that year's competition. So we had to find a solution that was less than 20 pounds, that could go up to 20-foot span, to ultimately replace aluminum ladders for our special forces in the Air Force.
Wow.
So we got to go down to Eglin Air Force Base down in Florida. That's that bottom picture with our professor in our ladder system, and run kind of a challenge course with a couple of the cadets there, which was super fun. We got to actually put it through the paces. And that design was really fun because it's full carbon composite, similar to our vehicle here. It can stove and fold it inside of itself into like little squares, and weighed, I think it was 14 pounds that we got down to. This carbon fiber is awesome.
Wow. Yeah, that's definitely something that I think a lot of people, when they think engineering, they're, I know a lot of students are thinking like cars and gears and mechanics, right? But we don't necessarily think about materials. That idea that materials can be really important. And that's something that you consider with the vehicles that you work on. Okay, so tell us, what is this? What are these gigantic chairs that we're looking at?
So that was the project I did right after college. So that summer after I graduated, my church got donated a bunch of first generation wood from California that were, 20-foot long planks, 14 by 18 tall, and they didn't know what to do with it. So our pastor's like, let's just build a chair for kicks and giggles and fun. Like, we can just do this. Let's just set a world record and just bring the community together around something. And so we built the world's largest Adirondack chair. I actually don't remember the final height of it, but we cut the top of the chair to mimic the mountains of Colorado. It was super fun. I got to be the analyst of it, to kind of do the material properties, make sure that, the thickness of wood to what we think the strengths were would be able to hold the weight. And yeah, it was a lot of fun. It was just a lot of people with a lot of muscle power with heavy things for summer.
Is it still sitting out there somewhere in a field?
It's not. So unfortunately, that chair, you can kind of see in the far right picture, there's a kind of a canyon back behind it that necks. A huge gust of wind, we think around 70 miles an hour, came and picked it up and threw it.
Oh my gosh.
Like, it was perfectly placed to just have a kite, a sail of a back of chair that just get picked up and thrown over.
Oh my gosh.
Weighing close to 9 tons.
I hope nobody was in the way. Oh man.
No, no one was around.
All right, so we want to hear a little bit. Give us your snapshot about you've told us a little bit about what you do, the hats that you wear. Specifically, we have some pictures here. Tell us first, like, what is it that you're standing in front of? And I want to show this so that people can see you as you're going through. So tell us a little bit about what we're looking at and what you do at Sierra Space.
So this again is our Reverence, our second vehicle of the Dream Chaser space plane line. First one is Tenacity. That one is at Armstrong Test Facility being tested. And here we build space planes. We like wings. We like soft landings. A lot of our competitors in our same field use capsules. So things that you put people inside of and they fall. And you get either picked up in Kazakhstan or the ocean. It has a pretty violent impact on the ground when you land on those. But this plane can land anywhere that, like, I think it's a 737 can land. That's the length of runway that we need. So effectively, any runway in the world where a normal 737 can land, this bird can land also.
That's crazy. I'm gonna
ISS. There's a lot of stuff up there that sometimes grows crystals, protein structures that if you shock them, they break and you instantly lose all the data that you've been growing up in space. So having a nice soft landing, we like to provide that to our customers so that they can grow stuff and actually get the data back here on Earth.
For sure. Yeah. Yeah. That reminds me of a competition challenge that we have that's a part of the curriculum that we do with the Space Lander, right? And
Yeah.
how students are asked to create something that can land softly onto the ground. And so I'm really interested. Now, I also want to say, you've been saying this term ISS, just for those of you that are watching, International Space Station.
International Space Station.
Yeah, that's that thing out in space that people actually exist in. It's like this little pod that you can go and do research and science all from there. And Chris, what if I'm hearing you correctly? Does that mean that you're taking supplies and things that we have on Earth and bringing people or bringing the supplies up to the International Space Station?
Yeah, so let me grab a little prop here that'll help me. So this is just an old model of our Dream Chaser with the cargo module on the backside of it. So our short mission is to fly up to the space station full of cargo. External cargo, internal cargo, just thousands of pounds of stuff. Food, scientific experiments, whatever it might be that the astronauts need up there. We'll fly it on up to the space station. They'll grab us with the Canadarm2, pull us into a berthing configuration, and unload us. So we don't have a crew member in here. It's all autonomous, so we're just having computers fly it for us. So we don't have to worry about that on the launch. And once we're up there, they just empty us out. They take 45 feet or whatever of stuff and fill the space station with it. Once they're done with us, once our mission's complete, they'll fill us back up. So the Dream Chaser will get filled up with stuff to come back to Earth. And the cargo module, on the way down, it gets thrown away. So we use this to throw away trash from the space station, which is kind of a problem because it's really hard to get rid of stuff on the space station. So on our flight in, we'll separate from the cargo module. It'll fall back in, burn up, and then this will come down and land on a runway.
Yeah. Oh, man, that's interesting to think about, the fact that we have space trash, but also we're not wanting to just exist in space. So bringing it back to Earth, and you're saying it's burning up. Oh, man, what are we doing with that? There's all these problems that I can think of that we need future engineers and scientists to figure out how to solve a little bit better, which is crazy to me. I love it.
Because leaving trash out in space is really bad.
Really bad.
Kind of having a problem of thousands and thousands of little pieces of trash just flying at 17,000 miles an hour, just waiting to hit something.
Oh my gosh. Yeah. And now I'll show these pictures here. This is kind of what you're talking about with this Dream Chaser being loaded up with all the supplies, right?
Yeah, so that top image is basically just a cutaway from right along this line here, showing just absolutely jam-packed with cargo. That's the advantage of, one advantage maybe of being autonomous, not having a crew member. We don't have to have someone crawl in there and then get smashed in with cargo and not be able to get out, or just at least lose space.
Right.
Every square inch, every cubic inch we can of this thing, we want to be filled with cargo, so we can get as much bang for the buck.
Yeah.
Sending stuff up to space.
Now, how long is one space trip?
It kind of depends. So obviously ISS has been up there for numerous decades. I think our first flight's going to be on the order of a month or two. Dream Chaser itself, can go for much, much longer, on the order of several months without refueling or coming back down. But it just depends on the mission profile of what they need.
Yeah.
If something's up there, it's taking up a port. If it's down here, we can be servicing it. We can be filling it back up, getting ready for the next mission. So it's always a trade.
Yeah, for sure. Okay. Can you briefly explain to us what these images on the right are?
Yeah, so the right images are from our cargo module. Actually, the bottom center one also is from the cargo module. So the cargo module, the very back side of it, has a hatch adapter plate that's our last bulkhead between us and the space station. So the green was the CAD version of what I designed, and then the silver is the actual final machined part that we had made out in Michigan, I believe is where we had it machined. That was my first part I ever designed. It took me 440 days to make.
Oh my gosh, that's a long time.
It was a long time. It was like my first year and a half here at Sierra Space. They trusted me. They gave me a lot of responsibility, and I got that bad boy out. And then that black and white image is us first, ingressing, going into the cargo module number one, kind of from the inside of the ship, looking back towards the inside of that hatch adapter plate. So got to be the first one to go in and welcome our vehicle when it got delivered a couple of years ago.
That's so neat. We love it. We love it. And I want to ask you more. I know we're going to do another time with you and I, and we'll get to talk more about this kind of connection. You talked about docking versus birthing. We'll discuss all of that here soon. So, but I want to conclude our little segment here with one of our favorite sections, which is called the rapid fire questions. These are not prepared. These are to the point. So the first question: what lessons from swing dancing have applied to your work?
Ooh, I want to deep dive that one. Maybe we can deep dive that one later, but I'll truncate it to space control. So in social swing dancing situations on a big dance floor, I'm only in control of my small area with my partner, but there's a dozen, 2 dozen. If you're at the Grizzly Rose here in Colorado, there might be 20 dozen other people on that floor, all vying for space. On this vehicle, maybe I can show you this real quick. There's tons and tons of stuff in here. Absolutely hundreds of components all across the inside of this vehicle. Every cubic inch is claimed. So when I go into a design on a vehicle with numerous other teams, numerous of my colleagues, all working and vying for the same space, all vying for mass, it's a similar game of, I need this space, I'm going to claim it, and I'm going to telegraph to everyone else that I'm going to take that space so that my hardware, my partner, doesn't get hit, I don't get hit, and everyone continues in their safe area without interfering with each other.
Yeah, absolutely. Thinking of like a big project, the fact that you said mass matters, right? So if we're taking this plane, we're taking this spacecraft, and people are working on different parts of it, well, they need to be able to communicate with each other. Mine's going to weigh this much and cost this much material and contribute to these constraints this way. Oh,
Yep.
Right on. Okay, here's the next question.
Okay.
Where on earth is one place that you would want to travel to?
I've always wanted to go to Lake Bled, Slovenia.
Oh.
Google it. It's gorgeous all areas of the year. It's just, I want to go so badly.
Right on. We love it. I'm going to have to look that one up. If you could have a different career, what would it be?
We want to be a professional soccer player. Just travel the world and play soccer professionally. That'd be just a lot of fun.
Absolutely. They have some crazy fans that do a lot of cool things. What technology do you think is going to be really useful for the future?
I think it's going to center around energy. So when I first graduated high school, our physics professor told us, in his kind of engineering group, to go design the next best battery, because batteries are super hard. As we've been learning recently with the cold weather and a lot of electric vehicles struggling in the cold weather and just dying, losing their charge, batteries and energy transfer are very difficult. So petroleum, gasoline is very nice because if you move it from, the UK over to the USA, it has all of its same amount of energy. You didn't lose a single, thermal unit moving it from one place to another. But batteries, if you take a AA battery, move it from here to Europe, you're going to lose some charge no matter what. That's why, a lot of companies will say they're good for 10 years, maybe, in the right perfect environment. So whether it's hydrogen, whether it's electricity, whatever it is, designing the next fuel source and being able to transport it, I think it's going to be very clutch to our future.
Absolutely, for sure. Okay, last question. What advice do you have for young students who are interested in pursuing possible STEM careers?
I think it's that you can do almost anything inside of it. So when I was in college, I did a lot of mentorship with our residents who were contemplating engineering and STEM, and sometimes struggling with it because it's a very difficult path. But I always would tell them that school is half about what you want to do and half about what you don't want to do. And so there's that dichotomy of you both have to learn the things you're really passionate about and the things you really want to contribute to and that you're skilled at, and the things that you know that you're not good at or don't feel successful at. So even inside of engineering, we have technical writers. They are people with an engineering interest, engineering kind of skill, but they don't really want to design parts, but they're very skilled at writing. They're super great at making our jargon of, spaceship, acronyms sound very intelligent and then very marketable to people that aren't engineers. So they really help kind of bridge those types of things. And it's super helpful to have all of those disciplines. I just use that as one example. We have every single discipline at our company effectively, but that's one that I think is very overwritten. Or that was a pun. I should have intended it, but very overlooked. That even some of the maybe it's liberal arts degrees kind of things, writing, communications. We have that all over here, and they're so vital to the success of this program, including all the engineering disciplines.
For sure. Oh, that's great. Yeah, absolutely. There's niches within different kinds of engineering and STEM fields that don't just have to be what we typically think of. There's skills that are needed. We need a wide variety of folks coming to the table. So
Right.
This has just been phenomenal. I am so thankful that you were here. I know we're going to get more opportunities to chat about what's behind you. So folks, tune into that. But for now, this closes out one of our Cosmic Career Chats. Chris, thank you so much for joining me, and we'll see you next time.
Thanks so much for having me, Rachel. Good luck, everyone.